Okay, some more problems from section 10.3. This is number 43, and what we want to do is, it says find the area of the region described, and inside the convex limacon, r equals 4 plus 2 cosine of theta. So I try to sketch it a little bit. I mean, you could always check this with your calculator, but you could try a few checkpoints just to see what it looks like. And if you go back and look over your gallery of polar curves, they talk about some of the ways of identifying what these are going to look like just based upon their form. If it looks like the cosine is going to be x-axis symmetry. And then we have our A and our B. And if that ratio is 2, it's going to be convex. So you can use that data to kind of have you understand that's going to be kind of almost like it's kind of like a little flat circle there. Okay, that's what it looks like. And I tried some checkpoints. When r is 6, theta is 0, that's theta is being 0. This is theta being pi over 2. Theta being pi, it's 2. That means I'm going to go out in this direction 2, not negative 2. Not like that, because the r is always going out from. So if it was this angle here, but it was negative. If it was negative 4, it'd be going backwards or up 4. So anyway, that's kind of a little idea of what it looks like. So basically, we just have our formula area equals the antiderivative from, or the integral from alpha to beta of 1/2 r squared d theta. And then here, in order to get this whole limacon, you have to go from 0 to 2 pi. That's the tricky part. Okay? And then we just put this in, 1/2 4 plus 2 cosine of theta. And then we just use symmetry because the top part and the bottom part are going to be the same. So I'm going to go from 0 to pi and then pi to 2 pi. So I just made it from 0 to pi. So I can take this 1/2 out. It's a little less numbers to deal with. So I brought the 1/2 out and put it in front. And then when I squared this out, using just a binomial squared, I got 16. 4 times 2 is 8. 2 times that is 16 cosine. And then 2 squared is 4 cosine squared of theta, all d theta. And I could take a 4 out of here. So I took a 4 out. And I had these numbers in front. So 2 over 2 cancels. I just had 4 times the integral from 0 to pi of 4 plus 4 cosine of theta. And then I've got to use my reduction formula. It's over on page 565. If you didn't want to derive it from the 2 angle formulas, you could get it from the 2 angle formulas. And your Pythagorean identities, you could derive this easy enough. But if you just want to remember it because we're using it a lot, probably the easiest way is to put it on a flashcard. So it's 1 plus the cosine of 2 theta over 2. And then what we could do is we could, then what I did was I went back and I got a 2 out of here to multiply out, to simplify this. So I kind of went backwards. So I took one of the 2's out of here. So 2 times 4 is 8. 2 times 4 is 8. 2 times, and then if I separate this, this would be 1/2. So 2 times 1/2 is 1. And then the 2 times that is just the cosine. So I don't want to get you fouled up here. So I use this 2, and I kind of put an extra step in here. I kind of skipped a step, so this was different work here. So ignore the orange, and if I multiply by 2, that's 8. That's 8, and then this cancels out, so I just have 1 plus the cosine of 2 theta. So I end up with something like this. Let me just block that out so you can see. Okay? But I want to take the antiderivative, and I'm going to have to use a u substitution. So I kind of doctor this up. Okay, what's the derivative of, if I use u as 2 theta, what's the derivative of 2 theta? 2, so I need a cosine of u du if I want to take the antiderivative. So the du would be 2 d theta. I got the d theta, I just need the 2. So I put a 2 there, but I just can't put a 2 arbitrarily there. So I put a 1/2 in front. Okay. So there we go. So we take the antiderivative. We've got the 2 in front. We're going to evaluate from 0 to pi. Let's get this up a little bit so you can see the finale here. And this I had to do to doctor this up. So the antiderivative of the cosine is the sine of 2 theta with the 1/2 in front. Now, if you take a look at that, remember, if you take the derivative of the sine, what do you get? You get the cosine of 2 theta times 2. and those 2's would cancel, so you would end up with that. So that works. Okay? So, and then 1, the antiderivative of 1 is theta. It's all with respect to theta. Okay? So that becomes theta, 8 theta, 8 sine of theta, the antiderivative of the cosine is the sine, and 1/2 the sine of 2 theta. And then we just evaluate it from 0 to pi, and we're going to double that because we use the symmetry. So I'll come back. So we've got 8 pi, okay? The sine of pi is 0, and another 1 pi. I could have simplified those. And then 1/2, and then the sine of 2 pi is 0. Okay? And then this is, if I put 0 in, that's all 0, 0, 0, 0. So it just ends up being 9 pi, 2 times 9 pi is 18 pi, and you're done. Okay? So you could have done it differently, you know, as far as how to simplify it. It's up to you. Hope that helps.